James pushes a box with a mass of 45 kilograms along the floor. He exerts a force of 258 newtons. The box accelerates to the right. What must be the coefficient? This is devilishly tricky, right? So not only are we going to find the friction force, but we have to go and find the coefficient of friction. Okay, so that's actually not so hard. I think what we're going to do is we're going to set up an F equals ma and solve for what that other force of friction is, right? And then we're going to, over here, right, we're going to use force of friction equals mu times m times g. We'll know the force of friction, we know the mass, we know g. We'll be able to find the coefficient, right? So let's draw a little picture here. Here's the box, right? He's exerting 258 newtons. There's some unknown force that we just know darn well that force is going to be to the left. But let's just let it fall out in our laps as negative. And then we just set this thing up, right? So let's go F equals ma. So F plus 258 equals 45. And then it must be accelerating that way, right? To the right. So positive 2.1. Oh, now I labeled one set of units. Ah! Okay. What am we going to do? I guess we're going to go this times this minus this. 45 times 2.1 minus 258. I get negative that the force of friction is, the unknown force is negative 163.5. Okay, so now I'm going to put that guy over there. I'm going to put it positive because in this context you don't really think of friction forces as negative unless you want a negative coefficient, right? Okay, so negative, positive 165. Oh, it's been a long day. 163.5 equals mu times 45 times 9.81. Okay, now we're set. Now we can find mu. Okay, divided by 45, divided by. And I'm getting that mu is ooh, that's cool. 370 repeating. 370, 370, 370, 370, 370. With two sig figs, it's 0.37. Yay! Yay!